Let's add our utilities to our library. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. The first helper method that I want to have as a util is a class that is related to positions. Because we know that in Minecraft, handling positions relative to directions are a little bit complex. We had a video about it, you can go and watch it. But I want to make my life easier. So I will say public static. This one returns a block pose array and we call it position next to. And here we send in a block pose pause. Okay, what do we want? We return a new block pose array of pause.up, comma, pause.down, comma, pause.east, comma, pause.west, comma, pause.north, comma, pause.south. So we are sending the position of every block around ourselves. Now I want an overload of this and I will call position side to. This means that we don't want the top or down. We just need the blocks that are sitting on the same level. The next one is an overload that we say side and then we want the bottom. So all we are ignoring is the top. Another overload side top. And here we are ignoring the down. And finally, position top down, top and bottom. So we don't want the sides. Okay, these are the easy ones. Now we go with the direction handling. So we say public static direction from netminecraft util left of the direction facing. So we are facing on some direction and we want the left side compared to our own facing. We return a switch based on facing and we say if the case is north, we want direction dot west. If the case is south, we want direction dot east. The case is west, we want direction south. If the case is east, we want direction dot north. And if it's top or bottom, then the default is the facing itself. Now, if you are confused what is going on here, go watch the video that we have on the cheat sheet for the facing directions and their relative comparisons to each other. We had a cheat sheet for this and you can use that. Okay, I will copy this and I will change it to right. You can guess that things will change. So if it's north, now we sweep the west and east and we sweep the north and south because we are looking on the opposite direction. Okay, then the front. So using our cheat sheet, now we know that here we use the south, here we use the north, here we use the east, and here we use the west. Copying the front, we now have the back. And again, we sweep the north and south here, east and west here. Now, here's the thing, we have the block pose.offset, but that is not relative to the facing. What we want is to be able to use the facing and then offset to the left, right, front, or back. So I will say public static that returns a block pose left, but this time I will send in a block pose pause and a direction facing. So we return the pause.offset. However, here we call our own overload and we send in the facing. So by doing this, we get the relative left based on facing and then we get the left position, not the normal offset, I don't know, southwest, blah blah blah. Copying this, I will put the right and all we are doing, we are calling the right, then front and back, and this is back. Obviously top and bottom does not have relative facing, so that's it. I can go with top and bottom. Why not? Just to make things complete, I will say top, and of course I don't need the direction anymore. All I'm doing is saying pose.up. This is crazy, you know, this is just unboxing something, but I don't know, I just want my library to be complete. We have something else. If we want to get a direction relative to another direction, this is what we will use. Public static returns a direction. We say relative direction. This one is nullable and we say direction, direction. And then another nullable, we call it direction, and this one is facing. So for example, we want to get the west relative to north, something like that. Here we say if direction equals to null, return null. If facing equals null, then we return the direction because we are not facing anywhere. Then we ask if direction.getAxis.is vertical, so we are looking up or down, then again we want to send back the direction. We don't have any horizontal relative relationship. And finally, we go with saying direction relative equals to the direction to begin with. Then we say for int I equals to 0, I is less than the facing dot get ID, I plus plus, and then we say relative equals to relative dot rotate y clockwise, and finally we return the relative. Now here we have a little bit of problem. It says cannot apply int to string. Now get ID returns the ID, and if we find the ID use cases, okay, this is changed in the recent versions. Now ordinal returns an integer, returns the ordinal of this enumeration constant, its position in its enum declaration, where the initial constant is assigned ordinal of 0. Most programmers will have no use for this method. It is designed for use by sophisticated enum-based data structures such as enum set and enum map. I think ordinal will solve our problem, but let's see. Yeah, I will go with ordinal. Hopefully this will work. Okay. Now, ordinal is basically saying that, hey, we were south, so this is 0, 1, 2, 3, and we'll look through that. That's our position helper. Then we have the math helper that we want to add some things to the math util. Actually, I call it math util, and I will call the other one post helper. I got used to the name helper, so I will change this one to math helper. Okay, the math helper will have something like this: public static float get chance from an int value. Now get chance returns this 100 minus value divided by 100, means that it will convert an integer to a float from 0 to 1. Another thing is this guy, public static boolean get chance, and this is the word and int value. We return the word dot get random dot next float to be greater or equal to the get chance based on the value we sent in. Now if you so want to, you can add int providers in here as overloads. Honestly, I don't see why you would have something like that, but if you want to, you can add them. So basically this would become something like this. Instead of int, I will go with int provider, and we call it int provider, and here we say int provider dot get value. Okay, that's it. Now the last thing that I want is an enum. Now this enum may make you confused. I will explain what's going on here. You say mapped direction. Now we know that in vanilla we have a direction enumeration, and I already showed you the direction enumeration. So what's the deal? If we have up, down, north, south, west, east, why would I have my own enumeration? Let's take a look. We have down, up, north, south, west, and east, but then I will add something called none. This will become handy when I have the directional storages in future in actually another library or multiple libraries. Basically, I want to bind a storage to a direction, but at some point I may want to have a storage that is not bound to any direction. So what Turtiburti had done was using null, and if you notice in our position helper, by the way, this is the code that I think he was in producing, but I'm not sure. He used nulls, and this is why he is asking for null comparison. But I thought to myself that, you know what, I can make my own enum and I will use none, and that is easier to understand. It will not cause any null point exceptions, it will not cause any crashes, and if things are not working, basically I will get some error messages in the log files, or I can debug the code without crashing the game and stuff like that. So this is the reason. Not only that, by the way, the code will be much more readable because we are saying map direction dot none instead of sending a null as the direction. All we have to do now is to make sure that we can convert our map direction to the vanilla direction and back. So what we will have here is a private static final, actually, a by map of the vanilla direction to our mapped direction, and we call it by map. Then in the static code, we say by map equals to util.make from net Minecraft util hash by map dot create, and then after the create, we want the map lambda, and here we will say map dot put. This is the directions from the vanilla. So if we have null, we want map direction dot null. Copy it and paste it. This one is direction dot down equals to our down. Copy paste. The up is again our up. The default north is our north. The default south will be our south. The default east will be our east, and the default west will be our west. And that's it. So all we are doing is binding null to our own none. Then we will have two methods. One is public static map the direction as the return type, and we call it from. And here is direction from vanilla direction. So we return from the by map, we get from the direction key, we have the public static that returns a direction actually, and we call it to, and the mapped direction as the direction. So we return from the by map dot inverse dot get direction. Okay, now we could add a little bit of additional naming like from direction and to direction. I think that makes more sense because when I say map direction dot to, I would think that I'm converting to map direction. But when I say map direction dot to direction and map direction dot from direction, it makes much more sense in my brain at the very least. Okay, that's our util classes all done and finished. In the next video, we will come back and start adding few different things like interfaces, and we will start working with block and block entity base structure that we will use in future.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun everyone. Bye.